Watch to the end. The most interesting part is at the very end. Branchipolynoe seepensis is a deep-sea scale worm, a polychaete annelid uniquely adapted to life in one of the most extreme and chemically unusual habitats on Earth, hydrothermal vents and cold seeps. Unlike most worms that crawl openly across the seafloor, this species lives almost its entire life hidden inside the mantle cavity of large deep-sea mussels, primarily from the genus Bathymodiolus. This is not parasitism in the classical sense. Branchipolynoe seepensis does not consume the tissues of its host. Instead, it occupies a protected internal space, benefiting from shelter and access to nutrient-rich water currents generated by the mussel's filtering activity. This relationship is best described as commensalism. The worm benefits, while the mussel is largely unaffected. The body of Branchipolynoe seepensis is dorsoventrally flattened and covered with overlapping scales known as elytra. These scales are thin, flexible, and lightly calcified, providing protection without restricting movement in the confined interior of the mussel. Coloration is typically pale to translucent, an expected trait in an organism that never experiences light. An exclusive anatomical detail, rarely mentioned outside specialized annelid literature, concerns the worm's respiratory adaptations. Branchipolynoe seepensis possesses highly vascularized branchial structures along the body margins that dramatically increase oxygen uptake. This is critical because the mantle cavity of deep-sea mussels can experience fluctuating oxygen levels due to both bacterial metabolism and seep chemistry. The worm's respiration is therefore tuned not to stable oxygen-rich water, but to chemically dynamic microenvironments. Feeding behavior is opportunistic. The worm consumes suspended organic particles, mucus, and microbial material present within the mantle cavity. It does not damage gill tissues, a key reason the association remains non-destructive. In environments where food input is unpredictable, exploiting an existing filtration system is an efficient survival strategy. The habitat itself is hostile by surface standards. Cold seeps and hydrothermal vents are rich in hydrogen sulfide and methane, compounds toxic to most animals. The mussels hosting Branchipolynoe seepensis rely on chemosynthetic bacteria to survive, and the worm indirectly benefits from this system by residing within a stable, chemically moderated niche. Mobility is limited but sufficient. The worm moves slowly within the mantle cavity, adjusting its position to optimize water flow and oxygen availability. Rapid movement would be energetically costly and unnecessary in such a confined and protected space. Reproduction remains poorly documented, but like many deep-sea polychaetes, Branchipolynoe seepensis is believed to release gametes into the water column. Larval stages are likely free-living before locating a suitable mussel host, a process that depends on precise chemical and environmental cues rather than chance. Branchipolynoe seepensis demonstrates that survival in the deep sea is not always about strength or speed, but about integration into existing biological systems. The deepest parts of the ocean are not barren deserts, but complex ecosystems shaped by chemistry rather than sunlight. Sylvia Earle. This worm exists because it exploits stability inside chaos, turning another organism's survival strategy into its own. Adaptation is not about perfection, but about sufficiency under given conditions. Stephen J. Good. If this changed your understanding of deep-sea life, please support the channel. Like the video, subscribe, share it, and tell us in the comments which deep-sea symbiotic organism you'd like to explore next. Let's discuss in the comments.